So the next big jump was essentially by folks such as Gene Merchant, who worked with the Cincinnati Millicron, a big machine tool company in the U.S. in the early days, one of the leaders, began looking at this and realized that there was a lot of activity going on as part of the production line, that is, as part of the defined space in which you added value to the product that didn't really add value to the product. As an example, you had to set up the machinery, and you had to mount the workpiece, and you maybe had to play around with the tooling, or you made some sort of adjustments. And if this was done while the assembly line was running, it was inefficient, so the assembly line or the machine would be stopped, and these changes would be made. So Merchant observed that, in a sense, most of these things were not adding value. They were doing things that set up the machine to add value, and since you buy the machine to make parts or to machine or remove metal, anytime it's not doing that, it's not efficiently operating for your system. Think of an airliner that pulls into a terminal. The plane is designed to move passengers and freight. Anytime the plane is not in the air moving passengers and freight, it's not returning value to the owner of the airline. So the emphasis then is to efficiently, as much as possible, turn that plane around and get it going. Now, thankfully, and unfortunately, you can't make repairs on the airliner while it's flying. Service companies are thinking about how to track what needs to be done so when it lands it can have a faster turnaround time. But that's kind of trying to get the machine to operate as efficiently over its cycle as possible by removing non-productive elements. So Merchant came up with ideas that led to automated manufacturing, flexible manufacturing systems, things like numerically controlled machine tools that could be programmed offline so that you didn't have to do the hand operation that was necessary, use of lazy Susans or carousels to load and unload parts very rapidly, adjusting tooling offline, et cetera, et cetera. So we externalized a lot of these non-productive elements. And the way we talk about efficiency of the cycle is we kind of look at the total time that value is being added to the product, and we compare that to the total time that the product is in the system, and that ratio gives you some sense about how efficiently you've externalized these non-productive elements, and you'd like that to be as close to 100% as possible. So in that means, then, Merchant began and others to reduce these things. So building on that and moving to the next stage, we see this kind of change from flexibility, which was really a way to make large lot sizes more efficiently by using the machinery more productively and externalizing the non-productive things, to a trend towards non-large or small lot production, more flexibility. Consumers want a bazillion different kinds of varieties in terms of their part quality and part type, et cetera, et cetera. So essentially you're trying to figure out a way to enable that, but keep the efficiencies that were seen in the earlier shifts. The trick to that is variability, repeatability. If I can guarantee that my process is going to make the same part the same way each time reliably, regardless of subtle variations in the material flowing in or the temperature of the room or whatever conditions, fluctuations in the power supply or whatever, then I can guarantee that when a customer pulls a product by buying it at the store, think Dell or online, and the order flows back up through the system, I can turn my system on, or I can arrange my system to produce that part with the same efficiency as if I was Henry Ford turning out thousands of Model Ts. This, in a nutshell, is kind of what the Toyota Production System, or TPS, enabled, and the features of which are on the screen right here, enabling small lot production. The big issue is this quality at the source. Okay. So what was introduced was the idea that unless I can absolutely control every aspect or every significant aspect of the production process, then there are elements that are outside of my control and in fact could introduce some variability in the process, which means I might generate a defect, I might not be able to make 100% yield, therefore I'm going to have some sort of backup stock and buffer, et cetera, et cetera. So by going to this idea of first part correct, small lot production with the same efficiency of large lot production, but guaranteeing that the quality and the quality was going to be high, variability was going to be low, I don't need a buffer. I don't need to make up for the fact that a part may not come out the way I expected it, So to keep the line running, I've got to throw one in from a buffer stock, or I've got to have a large inventory of pieces. So the whole concept of just-in-time, minimum working capital, ways of extracting the duplication which comes from a requirement to cover a process which is not under control were removed. And of course, an important part of that was the involvement of the supplier. So this allowed you to pull the production through the system, sort of make on demand or build to order, and allowed a tremendous level of reliability to occur, rippling through the supply chain, so that all of the heavy inventories and buffer stock and repair of a part and maintenance and backup for keeping the manufacturing operating smoothly could be eliminated, and the value of that extracted and either passed on to the consumer or passed on to your investors, or given to make more flexibility in the face of variability that might occur due to the external market sources or forces that you may have to be dealing with. So this gets us up to a system which essentially has tremendous capability, has high quality built in, so we can know what's coming out of the system as part of the process, has that quality rippling back through the supply line, has an ability to externalize most of the characteristics that are not productive or non-value added, thanks to merchant, has the specialization of labor that came in because of Taylor's kind of activity, and gives us a rather efficient production process. So we find ourselves essentially at that interface now and looking towards the future to see what kind of things are going to be happening and what's going to occur. So if I sort of look into my crystal ball and judge where things are going, my prediction then is that the next big shift is going to be towards what we would call sustainable production. And we're going to talk more about sustainability and where green fits in, et cetera, in a couple of slides. But for the purposes of this discussion, we generally incorporate within the concept of sustainability a reasonable coordination between influences from the economy, the environment, and society. So these all have their own definitions and all have their own evaluations. We are usually pretty good at evaluating economic impacts, capital return on investment. We are very good or getting better at assessing environmental impacts in terms of pollutants and greenhouse gases and CO2 and carbon equivalents, etc. The societal issue is still a little bit uncertain, but it relates to a number of things that we might expect: quality of life, health care, turnover rates of employees, the ability of the employee to take some control over their life, et cetera, things that you would find to be quite reasonable. The issue is, at this stage of the game, these costs associated with environmental impact, which could be the use of energy and its impact, it could be the use of materials and its impact, it could be the use of other resources, it could be what happens at the end of life of the product in terms of where it goes, whether it's reincorporated into the supply chain, whether it's just reused, whether it's landfilled or it's burned to get energy or whatever. And of course the societal costs in terms of health impacts from manufacturing or product use, etc., are pretty much not borne by the manufacturing chain or by the manufacturer. Now, you may disagree or you may quibble as to whether or not that's something that should be done, but the fact of the matter is that as we'll see, things are moving towards the insistence that that be included. So my argument is that we should sort of take advantage of that, start including those kinds of costs. Certainly the cost of energy is easy to see how it plays a bottom line impact on the cost of the product. But if you think about all the drivers that we're going to mention in a minute in terms of regulations and waste reduction, et cetera, in fact, we can find ways to extract value just as these previous folks did, Merchant and Taylor and the Toyota Production System folks, extract value from the cycle that makes our manufacturing much more efficient, more economical, less impactful, and in fact gives us substantial competitive advantage over folks who aren't doing it, or at least allows us to play in markets where that portion or that concern about impact from the environmental issues, energy issues, is considered to be important and is being regulated.